A model can generally be thought of as having parameters that one wants to vary and some standard analyses that are wanted for each variation. The common types of parameters that users wish to vary include material properties, position of parts, orientation of parts and sizes, or distortion of part shapes. This is the same solved quick start model as in part 1 of the Magneto tutorial video. From the menu bar, select Solution, define Parametrics, then Parametric Setup. The Parametric Setup dialog will open. Click the Create button in the lower left corner of the dialog. The Parameter Editor dialog will open. The default parameter, type, geometry displacement shows up. We will change this to geometry rotation. However, you may wish to browse the list to see the various parameters that can be set up. Edit the name, steps, and target point as shown here. Click the Select Geometry button. The dialog will close while you select the geometry. Either use Region or Object Selection and click once to select the rotor. When the ring highlights green, right-click to end selection. The dialog will reappear and the rotor geometry is highlighted green, indicating the parameter will apply to. Click Apply Create. The Parametric Setup dialog will appear again, but with your defined parameter now in the Parameters Defined list. The geometry corresponding to the selected parameter, the only one in this case, is highlighted green. To visually confirm what the setup parameter will do, select Validate button on Parametric Setup dialog box. To visualize the total parametric setup, click the two arrows highlighted below to toggle the display to the fully expanded dialog. The defined outputs don't appear under post-processing here. That list is for the temporary outputs that can be obtained from the Analysis menu. From the menu bar, select Analysis, Torque, then Virtual Work on Region. The dialog will disappear, and the command line will prompt you to select Geometry. Select the rotor. The command line will show the prompt Locate or Enter the torque point. Set the torque point, then press the Enter key a second time to end the torque command. Right-click to end selection. The dialog will reappear, and the post-processing will show Torque Virtual Work on Region. Next, we will set up the flux linkage calculation. From the menu bar, select Analysis, Flux, Linkage, then Region, and select Forward Coil. Select Return Coil when the command line prompts to select Flux, Linkage, Return Source Selection. The parametric post-processing settings in the Parametric Setup dialog box will update to show the flux linkage calculation. Left-click the Close button. Save this model and from the menu bar, select Run Parametric, Perform Parametric Analysis from the Solution menu. A dialog will open, prompting you for a database name to save the results in. It is recommended to modify the name to Magneto, Quick Start, Sample 2 Results. The solver will now iterate through all the requested parametric variations. When it is done, the final parametric table will appear. Click the Graph Results button. Set the Graph Results dialog as shown, and click on Graph Results. A graph will appear showing the torque versus the parametric step number. Click the Close button for all open dialog boxes. We will close the Graph Results window. We can also plot flux linkage from parametric analysis results. On right-clicking the graph curve, the graph menu opens, and the differentiation option can be used to produce a derivative graph from which we can plot generator voltage. Scripting via the API is the other major way of automating the use of integrated software. Scripting takes more setup time than parametrics, but offers much more power. While parametrics are restricted to studying systematic variation of existing model parameters, scripting offers many more possibilities. To run a script for first time on your computer, some extra setup will need to be done. Close Magneto and using Windows Explorer, navigate to the folder when Magneto is installed. Right-click on the file, is.axe. In the pop-up menu, left-click Run as Administrator. Magneto will open in a special mode, which sets up the Windows registry for external scripting control. Close Magneto. The scripting examples are provided in a zipped folder placed in your document folders. Double-click on API Samples zipped folder. Inside this folder is a zip file, also named API Samples. Right-click on the API Samples zip file and extract all. Navigate into the API Samples folder. Double-click the Excel folder to open it and double-click the file, Magneto Orsted. Quick electromagnet sample to open it. You will probably be prompted with a warning message about the macro in the spreadsheet. Click the Enable Content button. Now start Magneto normally and click the Run Magneto Sample button on Excel sheet. While the macro runs, both Magneto and Excel will be locked. The macro will move the plate by the number of positions and report the force at these positions. When the macro has completed, the spreadsheet will show a data table and plot of the force versus number of positions. This example shows a very quick, limited use of scripting. Similar targeted tools can be developed as scripts, but much more ambitious custom design tools, even involving creation of the model, can be created.